Picture a void where the laws of physics unravel, where gravity twists space like taffy, and entire stars vanish without a trace. These aren't scenes from science fiction. They're real cosmic nightmares, places so deadly that even light itself can't escape their grasp. Welcome to a journey through the top 25 most dangerous places in the universe, where extreme conditions defy imagination and survival isn't just unlikely, it's impossible. From black holes that devour everything in their path to rogue planets drifting through the icy darkness of space, each of these locations is a testament to the raw, terrifying power of the cosmos. Think you know what extreme means? Try standing on the surface of a neutron star, where a single teaspoon of matter weighs as much as a mountain. Or imagine wandering into the path of a gamma-ray burst, a cosmic explosion so violent it outshines entire galaxies in seconds. These aren't just theoretical dangers, they're real, lurking in the depths of space, waiting to remind us just how small and fragile we truly are. And yet, there's something undeniably captivating about these monstrous places, a mix of awe and dread that pulls us in, demanding we look closer. This isn't just a list of cosmic hazards, it's a tour through the universe's most unforgiving frontiers, where temperatures soar hotter than 1,000,000 suns and magnetic fields could rip atoms apart. But why explore them? Because hidden in their violence are clues to how the universe works, secrets about the birth and death of stars, and even the fate of galaxies themselves. So buckle up, we're about to venture into the darkest, most violent corners of existence, where danger isn't just a possibility, it's guaranteed. Most people think the sun is just a giant ball of fire, but its true terror lies in the invisible inferno surrounding it, the corona. This wispy outer atmosphere stretches millions of kilometers into space, a place where temperatures rocket to over 1,000,000 degrees Celsius, hotter than the sun's surface below. How can the air around a fire burn fiercer than the fire itself? Scientists still debate the mystery, but one thing's certain: the corona is a ticking time bomb of solar fury. Here, tangled magnetic fields snap like rubber bands, unleashing solar flares explosions with the energy of 1,000,000,000 atomic bombs. They blast radiation across the solar system at light speed, frying satellites and scrambling radio signals in minutes. But the real nightmares are coronal mass ejections, billion-ton clouds of plasma hurled into space. When one struck Earth in 1859, the Carrington event, telegraph systems sparked and caught fire, and auroras lit the skies as far south as Cuba. If something like that hit today, power grids could fail globally, plunging continents into darkness for months. Yet the corona isn't just destruction, it's also breathtaking beauty. Those shimmering tendrils you see during a total eclipse, that's the corona's glow, superheated gas dancing along magnetic loops, a reminder that even in the universe's deadliest places, there's terrifying magnificence. And for all our technology, we're still at the mercy of this solar monster's next outburst. At the very center of our Milky Way, hidden behind swirling clouds of cosmic dust, lurks a monster so immense it defies comprehension: Sagittarius A. This supermassive black hole weighs 4 million times more than our Sun, a gravitational titan around which the entire galaxy slowly spins. Picture the most crushing weight you can imagine, now multiply that by an unfathomable scale. Even light, racing at 300,000 kilometers per second, can't break free once it crosses the event horizon, that point of no return where the laws of physics as we know them simply cease to exist. Stars unfortunate enough to drift too close don't just get pulled in, they undergo a process as horrifying as its name suggests: spaghettification. Imagine a star, a massive sphere of burning gas, stretched into a thin, glowing strand like cosmic pasta. The black hole's gravity is so intense that its pull on the star's near side is vastly stronger than on its far side, ripping it apart atom by atom. And yet, for all its destructive power, Sagittarius A is eerily silent. No screams, no explosions, just an endless, crushing darkness where even time itself distorts beyond recognition. But don't mistake silence for inactivity. This colossal predator feasts on whatever strays too near, heating gas to millions of degrees and creating flickering X-ray flares that betray its hidden presence. What's truly unsettling, we're orbiting this beast right now 27,000 light-years away, locked in a cosmic dance with a force that could shred our solar system without a second thought. One wrong move and everything we know could be stretched into oblivion. Yet, despite its terrifying nature, Sagittarius A star holds secrets about how galaxies form, evolve, and eventually die, making it one of the most captivating and deadly objects in the known universe. Black holes are terrifying enough when they stay put, but what if one decided to go for a stroll? Enter rogue black holes, the universe's ultimate drifters. Unlike their supermassive cousins anchored at galactic centers, these nomads roam the cosmos unseen, untethered from any star system. With no glowing accretion disks to betray their presence, they could slip through space like shadows until it's too late. Imagine a black hole the mass of 20 suns, barreling through our solar system at 500,000 kilometers per hour. By the time we noticed its gravitational fingerprints, planets yanked off course, stars warping in strange directions, Earth could already be doomed. First, the outer planets would vanish. Neptune's orbit might stretch into a grotesque ellipse before the ice giant itself was shredded into a swirling river of debris. Jupiter's storms would twist into spirals as its atmosphere was siphoned away like smoke into a cosmic vacuum. And then, the black hole's tidal forces would start playing with Earth like putty. Here's the chilling part: we wouldn't see it coming in any traditional sense. No ominous dark sphere blotting out the sky, just the nightmarish side effects of space-time itself being knotted beyond recognition. Tides would surge thousands of feet high as the moon's orbit destabilized. Earth's crust would crack from gravitational stress, unleashing planet-wide earthquakes. And if we somehow survived that, the black hole's gravity would slingshot us into the freezing void, a frozen relic hurled into interstellar space. Yet rogue black holes aren't just agents of chaos, they're cosmic archaeologists. Their paths might trace the violent mergers of ancient galaxies or reveal hidden dark matter highways weaving through the universe. Some could even be primordial black holes, left over from the Big Bang itself, carrying secrets about the birth of reality. That's the irony. These invisible reapers, capable of erasing worlds without a trace, might also hold the keys to understanding everything. If black holes are the universe's ultimate destroyers, magnetars are its most unpredictable berserkers, neutron stars that took cosmic danger and cranked it up to 11. Picture the collapsed core of a dead star, barely 20 kilometers across, yet weighing more than our sun. Now amplify its magnetic field to a level that defies reason, a quadrillion times stronger than Earth. That's a magnetar, a ticking time bomb of electromagnetic fury. These monsters don't just bend the rules of physics, they snap them in half. Their magnetic fields are so intense, they twist the very fabric of space-time around them. Get within 1,000 kilometers, and that field would unravel your atoms, pulling electrons from your body like threads from a sweater. But the real horror begins when their crusts crack under the strain. Unlike Earth's earthquakes, a magnetar's starquake releases energy equivalent to 100 billion nuclear bombs in a millisecond. The explosion unleashes gamma-ray bursts, death beams of radiation so powerful they've been detected halfway across the observable universe. In 2004, a magnetar 50,000 light-years away flexed its muscles. Its gamma-ray pulse was so intense, it ionized Earth's upper atmosphere, disrupting radio communications worldwide. And that was from halfway across the galaxy. If one erupted within 20 light-years of us, the burst would cook our ozone layer, bathe the planet in lethal radiation, and potentially trigger mass extinctions. Yet magnetars are also cosmic Rosetta Stones. Their extreme conditions let scientists test the limits of quantum physics and relativity. Some researchers even believe their eruptions might explain mysterious fast radio bursts, those enigmatic deep space signals that have puzzled astronomers for years. So while magnetars are nature's ultimate electric chair, they're also keys to unlocking the universe's deepest secrets. A reminder that the cosmos's deadliest forces often hold its most profound truths. We think of space as cold, but nothing prepares you for the Boomerang Nebula, where the chill is so extreme, it defies the very laws of physics. At -272 degrees Celsius, this cosmic freezer is colder than the vacuum of space itself, just 1 degree shy of absolute zero, the theoretical limit where all motion stops. To put that in perspective, if you stood there unprotected, your molecules would freeze in place faster than a blink, your breath turning to ice crystals before it even left your lungs. What makes this nebula so unnaturally cold? The answer lies in its violent past. Once a dying star, it now expands at nearly 600,000 kilometers per hour, hurling gas outward so rapidly that it creates a cosmic refrigerator effect. Think of it like spraying aerosol. As the gas rushes out, it cools dramatically. But here's the twist: thermodynamics says things should eventually heat up again. The Boomerang Nebula laughs at that rule. Its expansion is so relentless, the cooling never stops, creating a pocket of frost deeper than anything nature should allow. Even more bizarre, this ghostly nebula isn't just cold, it's shaped like a cosmic hourglass with 2 symmetrical lobes of frigid gas stretching 3 light-years across. That's 3 times the distance from Earth to the nearest star, and at its heart, a star so frail it's barely clinging to life, its light too weak to warm even the dust around it. For comparison, Earth's coldest recorded temperature, -98 degrees in Antarctica, feels like a sauna next to this abyss. But the Boomerang Nebula isn't just a record breaker, it's a time capsule. Its extreme conditions mimic the early universe, giving scientists a lab to study how molecules behave near absolute zero. Some theories suggest its chill could even reveal clues about dark energy, the mysterious force accelerating the universe's expansion. So while this nebula might be the deadliest deep freeze imaginable, it's also a frozen key to unlocking cosmic secrets. Proof that even the universe's most inhospitable corners have stories to tell. Some stars don't just drift peacefully through the galaxy, they become cosmic bullets fired from the universe's most violent events. Hypervelocity stars race through space at over 1,000 kilometers per second, fast enough to cross the entire United States in less than 4 seconds. These aren't gentle wanderers, they're celestial fugitives, ejected from their homes by forces so powerful they defy belief. The likely culprit, the supermassive black hole at our galaxy's heart. When a binary star system drifts too close to Sagittarius A, one star may get captured while the other gets slingshotted outward at unimaginable speeds. Imagine a gravitational catapult launching a star with enough force to escape the Milky Way entirely. That's the sheer violence behind these stellar outcasts. But black holes aren't the only architects of chaos. Galactic collisions can also send stars screaming across the cosmos, ripped from their orbits when entire galaxies tear each other apart in slow motion. What makes hypervelocity stars truly terrifying isn't just their speed, it's what happens when they plow through the delicate fabric of space. A star moving this fast doesn't just pass through nebulas, it shreds them. Its bow shock compresses interstellar gas like a cosmic snowplow, triggering shockwaves that can ignite new star formation or prematurely detonate unstable stellar neighbors. Some astronomers theorize that a hypervelocity star could even destabilize a white dwarf, causing it to go supernova decades or centuries before its natural expiration date. The most famous hypervelocity star, known as S5 HVS1, is racing toward intergalactic space at nearly 2 million miles per hour. At that speed, it's not just leaving our galaxy, it's becoming a lone traveler in the vast emptiness between galaxies where it may drift for eternity. Yet, even in their isolation, these rogue stars serve a purpose. By tracing their paths backward, scientists can map the hidden gravitational tides of the Milky Way, revealing secrets about dark matter and the galaxy's turbulent history. So while hypervelocity stars might seem like galactic wrecking balls, they're also cosmic messengers, reminders that even in the vast stillness of space, violence can create unexpected beauty and new beginnings. Their stories teach us that destruction and creation are often two sides of the same celestial coin. The Large Magellanic Cloud might sound like a whimsical name for a dwarf galaxy, but don't let its size fool you. This cosmic neighbor is a powerhouse of stellar violence. Orbiting our Milky Way like a frenzied satellite, it's home to the Tarantula Nebula, a star-forming region so intense, it makes the Orion Nebula look like a quiet suburb. Here, newborn stars ignite in clusters so dense, their radiation sculpts the surrounding gas into towering pillars and cavernous voids. The Hubble Space Telescope's images reveal a landscape of chaos-ionized hydrogen glowing crimson, dark tendrils of dust weaving through the nebula like a spider's web, and massive stellar nurseries where stars are born at a rate 100 times faster than in our entire galaxy. At the heart of this maelstrom lies R136, one of the most massive star clusters ever discovered. Its brightest members are monster stars, each shining with the luminosity of millions of suns and spewing enough ultraviolet radiation to sterilize entire planetary systems light years away. These aren't just stars, they're ticking time bombs. When they eventually explode as supernova, their shockwaves will rip through the nebula, triggering new rounds of star birth and destruction in an endless cycle. But the Tarantula Nebula already has a grim trophy on its shelf: supernova 1987A, the closest observed stellar explosion in 4 centuries. When its light reached Earth in February 1987, astronomers witnessed something unprecedented: a blue supergiant detonating with the force of 100 million suns. For months, it outshone every other star in the Large Magellanic Cloud, its radiation flooding telescopes with data that rewrote our understanding of how massive stars die. The aftermath, a rapidly expanding debris field laced with radioactive isotopes, including enough titanium-44 to forge 100,000 Earths. What makes this dwarf galaxy especially treacherous isn't just its active star-forming regions, it's the sheer concentration of lethal radiation. Ultraviolet and X-ray emissions here are so intense, they've ionized vast swaths of interstellar gas, creating bubbles of plasma that stretch hundreds of light years. Any hypothetical planet near these zones would be scoured clean of atmosphere, its surface bathed in a constant stream of particle radiation capable of shredding DNA. Even more chilling, the Large Magellanic Cloud is drifting closer to the Milky Way, destined to collide with us in about 2.5 billion years. When that happens, its turbulent nurseries could ignite a new era of chaotic star formation right in our cosmic backyard. Yet for all its dangers, the Large Magellanic Cloud is a goldmine for astronomers. Its proximity, just 160,000 light-years away, makes it a living laboratory for studying stellar evolution up close. The Tarantula Nebula's extreme conditions mimic those of the early universe, offering clues about how the first stars might have formed. And supernova 1987A, its expanding remnant still glows in X-rays, a real-time tutorial on how stellar explosions seed the cosmos with heavy elements. So while this dwarf galaxy might be a den of celestial violence, it's also a window into the universe's most formative processes, a reminder that creation and destruction are often two sides of the same cosmic coin. Jupiter's moon Io looks like a cosmic art project gone wrong, a world where the paints were molten lava and toxic sulfur splattered across a canvas of perpetual fire. This isn't just volcanically active, it's the most geologically violent place in the solar system, with over 400 active volcanoes spewing fountains of lava dozens of kilometers high. The entire surface is a patchwork of neon yellows and fiery oranges, stained by sulfur compounds that would dissolve human flesh in seconds. If Dante needed a real-world model for his inferno, Io would be it, a place where rivers of lava replace water, and the mountains are actually collapsing volcanoes sinking into lakes of molten rock. What fuels this never-ending eruption festival? Jupiter's immense gravity. Locked in a gravitational tug-of-war with neighboring moons Europa and Ganymede, Io gets stretched and squeezed like a stress ball. This constant flexing generates so much internal friction that its core stays white-hot, turning the moon into a pressure cooker with no release valve. The result, lava flows so vast they drown entire continents, and volcanic plumes that shoot sulfur dioxide high enough to briefly escape into space, only to freeze and snow back down as neon-colored flakes. But volcanoes are just the opening act. Io's real nightmare is Jupiter's radiation belts, which bombard the moon with lethal particles at doses thousands of times stronger than Earth's worst nuclear disaster zones. An unshielded astronaut standing on Io's surface would receive a fatal radiation dose in under an hour. Even spacecraft have to be careful. NASA Galileo probe had its camera fried after flying too close, its electronics zapped by Jupiter's invisible death rays. Yet for all its hostility, Io holds clues to planetary evolution. Its constant resurfacing lava burying old terrain at a rate of 1 centimeter per year makes it a living laboratory for studying how worlds recycle themselves. Some scientists even speculate that volcanic exhalations might create temporary, wafer-thin atmospheres, proving that even in hellscapes there's room for cosmic surprises. So while Io might look like the universe's idea of a furnace malfunction, it's also a reminder that chaos and creation often share the same address. Venus might look like a serene pearl from space, a soft, glowing orb wrapped in thick white clouds. But beneath that deceptively calm exterior lies the closest thing to hell in our solar system. Landing on its surface is like stepping into a nightmare where standard physics seem broken. The air isn't just thick, it's a crushing ocean of carbon dioxide, pressing down with 92 times the force of Earth's atmosphere. That's equivalent to diving a kilometer underwater without a submarine, except here, the weight comes with temperatures hot enough to melt lead. 462 degrees Celsius blankets the entire planet day and night, a relentless fever caused by a runaway greenhouse effect that trapped the sun's heat for billions of years. Those beautiful clouds, they're not made of water, they're sulfuric acid, swirling in corrosive layers that eat through metal and stone. And when it rains here, the droplets vaporize before hitting the ground, creating a toxic haze of acid mist. Soviet probes like Venera 13 managed to transmit data for barely 2 hours before succumbing to the pressure and heat, their metal frames warping like wax. Even modern spacecraft would need armor capable of withstanding the surface pressure of a small nuclear blast just to survive long enough to snap a single photograph. The landscape is just as alien as the atmosphere. Radar maps reveal vast plains of volcanic rock, twisted into surreal formations by centuries of unimaginable heat and pressure. Towering mountains like Maxwell Montes higher than Everest bear scars from lava flows that might still be active, hinting at a world geologically alive beneath its suffocating shroud. And then there are the tessera, jagged highlands with fractures so deep they resemble shattered glass on a planetary scale. But here's the eerie paradox: while the surface destroys all life, the upper atmosphere might just harbor the solar system's most unexpected sanctuary. 50 kilometers up, temperatures and pressures mirror Earth's, prompting some scientists to propose floating colonies in Venus's acidic skies, a concept straight out of steampunk fantasy. It's a jarring contrast, a surface that annihilates probes within minutes, and a sky that could, in theory, host human pioneers. Venus doesn't just defy expectations, it obliterates them. A world born from the same cosmic dust as Earth, yet transformed into a cautionary tale of climate catastrophe gone apocalyptic. Studying its extremes teaches us not just about planetary science, but about the fragile balance that keeps our own world habitable. Venus is more than a warning, it's a mirror, reflecting what happens when a planet's delicate systems spiral out of control. The TRAPPIST-1 system sounds like a peaceful oasis, a dim red dwarf star just 40 light-years away, orbited by 7 Earth-sized planets. But don't let its compact size fool you. This cosmic neighborhood is a pressure cooker of extremes where the laws of planetary survival get rewritten daily. The star itself is a volatile runt, barely 9% the mass of our Sun, yet prone to violent tantrums, solar flares so powerful they can strip atmospheres clean off planets in just a few million years. And with all 7 worlds crammed into a space tighter than Mercury's orbit, their dance is anything but serene. Tidal forces here are relentless, like Jupiter's grip on Io, but multiplied by 7. The star's gravity stretches and kneads these planets, heating their cores to molten fury. The innermost worlds, like TRAPPIST-1b, might resemble giant lava marbles, their surfaces permanently scorched under a hellish twilight. But the real freaks are the outer planets, the so-called eyeball worlds. Locked in tidal rotation, with one side forever facing the star and the other plunged in eternal night, they could harbor surreal landscapes. Imagine a thin ring of habitability along the Terminator line, where glacial rivers from the dark side meet flaming lava fields under a blood-red sun. One wrong step and you'd either freeze solid or evaporate in an instant. Then there's the radiation bath. TRAPPIST-1 frequent flares blast its planets with ultraviolet and X-ray surges hundreds of times stronger than anything Earth experiences. Any potential atmospheres would be under constant siege, their molecules torn apart atom by atom. Some models suggest these worlds might resemble Venus's evil cousins, sulfuric acid clouds swirling over magma oceans, with lightning storms flashing through skies choked with vaporized rock. Yet, buried in all this chaos, there's a tantalizing possibility. TRAPPIST-1e, smack in the middle of the habitable zone, might just be the ultimate cosmic paradox. A world where tidal heating keeps subsurface oceans liquid beneath an ice shell despite the star's fury. If life exists there, it wouldn't be on the surface but in deep, dark abysses feeding on geothermal vents. A reminder that even in the universe's most unforgiving corners, nature finds a way, or at least a glimmer of one. So while TRAPPIST-1 planets might look like a lineup of celestial torture chambers, they're also a masterclass in planetary extremes. Studying their harsh rhythms teaches us how fragile or resilient worlds can be when pushed to their limits. Just 500 light-years from Sagittarius A star lies a killing field invisible to human eyes, an area where radiation doesn't just linger, it rages. The galactic center's deadly halo of gamma and X-rays isn't merely background noise. It's a continuous storm of high-energy particles, cranked up to levels that would make Chernobyl's reactor core seem like a mild sunburn. Generated by colliding stellar winds, supernova remnants, and the black hole's own frenetic feeding, this radiation zone turns space itself into a microwave set to annihilate. Step inside and your body would absorb a lifetime's worth of radiation in less time than it takes to blink. Survival here isn't measured in hours or minutes, it's counted in seconds. Without shielding, DNA would unravel almost instantly. First, the gamma rays would ionize your atoms, stripping electrons like a cosmic sandblaster. Then the X-rays would fry nervous tissue, disrupting cellular communication before pain signals could even reach your brain. By the 3-second mark, organ failure would begin as proteins denatured into useless clumps. 5 seconds in, radiation sickness would hit with the force of 1,000 sunburns layered over every square inch of skin. 10 seconds, game over. Your molecules would be so thoroughly scrambled that not even bacteria could feed on the remains. But here's the twisted irony. This lethal glow is also a beacon for astronomers. The very radiation that vaporizes organic matter acts like a spotlight on Sagittarius, a star's feeding habits. X-ray flares reveal where the black hole last tore apart a gas cloud, while gamma-ray bubbles map the paths of ancient supernova shockwaves. Some researchers even speculate that this radiation bath might explain the Fermi bubbles, gigantic structures of high-energy particles ballooning above and below the Milky Way's core. For all its violence, the radiation zone serves a purpose. It's a cosmic pressure washer, sterilizing the area so efficiently that any potential life forms would need to evolve far underground or beneath miles of ice. Yet paradoxically, those same deadly particles might have helped seed the galaxy with heavy elements, scattering the atomic building blocks for future planets. So while this region tops the list of places to avoid, it's also a reminder that destruction and creation in space are never truly separate, just different phases of the same endless cycle. Some stars flicker gently, like candle flames in a cosmic breeze, but KIC 8462852, better known as Tabby's star, doesn't flicker. It plummets. Imagine a sun that occasionally dims by up to 22%, as if a celestial hand keeps flipping a switch. These aren't the predictable dips of an orbiting planet, they're erratic, jagged nosedives in brightness that last for days or even weeks with no clear pattern. When astronomers first spotted this anomaly in data from the Kepler Space Telescope, it sent shockwaves through the scientific community. How could a mature star, one nearly 50% larger and 1,000 degrees hotter than our Sun, behave like this? The theories range from the plausible to the downright apocalyptic. The most unsettling explanation: alien megastructures, specifically a Dyson swarm hypothetical energy harvesting constructs built by an advanced civilization to encircle their star and capture its power. Picture millions of giant solar panels orbiting in dense formations, blocking starlight in chaotic clusters as they shift and rotate. While no definitive evidence supports this, the star's light patterns don't match any known natural phenomenon. Even conservative scientists admit, if you wanted to design a signal for an alien engineering project, this might be it. But nature has its own bag of tricks. Some argue Tabby's star might be shrouded in a monstrous cloud of comets, not just a few, but a swarm of millions, vaporizing as they spiral inward. To dim a star this dramatically, the swarm would need to be absurdly dense, like a celestial avalanche of ice and rock. The problem: no known comet family behaves this way naturally. Others suggest the star recently devoured a planet, leaving behind a swirling disk of debris that occasionally blots out its light. Or perhaps it's surrounded by vast rings of dust, twisted into bizarre shapes by the gravity of unseen worlds. For any planets orbiting this star, the reality would be a waking nightmare. Imagine a world where daylight doesn't just fade, it vanishes for months at a time, plunging ecosystems into freezing darkness. Photosynthesis would collapse, triggering mass extinctions. Then, just as suddenly, the light returns, scorching the planet with brutal intensity. Over millennia, these violent swings could strip away atmospheres, boil oceans, or lock entire worlds in permanent ice ages. Yet Tabby's star isn't just a cosmic oddity, it's a revolution in disguise. Its mysteries force us to question what we think we know about stellar behavior. Every observation, whether it points to comets, dust, or something far stranger, pushes the boundaries of astrophysics. And that's the thrill of it. In a universe full of predictable phenomena, Tabby's star is a wild card, reminding us that some answers might lie beyond the edge of our current understanding, or even, just maybe, in the realm of civilizations we've yet to meet. The Witch Head Nebula looms in deep space like a phantom, a 200-light-year-wide specter sculpted by violence. Its eerie, wispy outline resembles a face screaming into the void, but this cosmic wraith isn't just for show. It's the aftermath of a supernova explosion so powerful, the shockwaves are still rippling through interstellar space millennia later. Imagine tossing a stone into a pond, except the stone is a dying star and the pond is a sea of gas stretching across eternity. The result, a minefield of collapsing hydrogen clouds, each one teetering on the edge of stellar birth or catastrophic disintegration. What makes this nebula especially treacherous isn't just its size, it's the turbulence hiding within those ghostly tendrils. Gravity here works like a cosmic game of Jenga, pulling gas clouds into unstable towers that could collapse without warning. One wrong nudge and an entire pocket of gas might implode, igniting a chain reaction of star formation, or worse, triggering secondary supernova. It's a celestial domino effect where the stakes are solar systems, and nestled within these chaos-riddled clouds are protostars, infant suns flickering to life amid the wreckage of their predecessors. Zoom in and you'll spot another nightmare, rogue bullets of plasma. These are stellar shrapnel chunks of star matter hurled outward by the original explosion, now tearing through the nebula at hypersonic speeds. They carve cavernous bubbles in the gas, leaving behind voids where new stars can't form. For any hypothetical spaceship passing through, it'd be like navigating an asteroid field if the asteroids were invisible shock fronts and radioactive debris. Yet the witch head isn't just a graveyard, it's a nursery. The same shockwaves that rip gas clouds apart also compress them, squeezing hydrogen until it sparks new stars. Some of these newborns are monsters, dozens of times heavier than our sun, destined to explode and repeat the cycle all over again. That's the paradox of this place, destruction and creation locked in an endless dance, each feeding the other. For astronomers, the witch head is a time capsule. Its shockwaves preserve a fossil record of the explosion that birthed it, letting scientists study supernova in slow motion. The nebula's delicate filaments even hint at the original star's composition, heavy elements like oxygen and iron woven into its structure, the very atoms that might one day form planets or even life. So while this cosmic phantom might look like a portrait of death, it's also a canvas for the universe's next actor, a reminder that even in the darkest corners of space, endings are just beginnings in disguise. Deep in the constellation Serpens, a dead star spins at dizzying speeds 60,000 times a minute, blasting its surroundings with a rhythmic strobe of radiation. This is PSR J1719-1438, a pulsar so dense, a teaspoon of its matter would weigh 1 billion tons on Earth. But the real marvel, or nightmare, lies in its shadow, a planet that shouldn't exist. PSR J1719-1438b is a world of extremes where crushing gravity and relentless radiation have forged a landscape unlike anything in our solar system. This isn't just any planet, it's a cosmic diamond the size of Jupiter, its core compressed into crystalline perfection. Once an ordinary carbon-rich world, it was baked and crushed by its pulsar's fury until its very atoms realigned into a lattice of diamond. Imagine vast plains of glittering carbon stretching to the horizon, jagged crystal mountains reflecting the pulsar's eerie light, but this beauty is deadly. The planet's surface isn't just hard, it's sharper than any blade. A single misstep could slice through spacecraft hulls like paper, the crystalline edges honed to atomic precision by eons of radiation. And then there's the pulsar itself, a celestial predator. Its beams of gamma rays and X-rays sweep across the planet like a lighthouse from hell, delivering doses of radiation that would vaporize flesh in nanoseconds. The magnetic fields here are so intense they could scramble a supercomputer's circuits from 1 million kilometers away. If that weren't enough, tidal forces from the pulsar's gravity keep the planet locked in a vise grip, heating its interior to molten extremes. Some scientists speculate there might be rivers of liquid diamond deep beneath the crust, churning in slow motion under pressures that defy earthly physics. Yet the most chilling detail, this planet is a relic of cosmic cannibalism. PSR J1719-1438 wasn't always a pulsar. It was once a star like our Sun until it siphoned off so much material from its companion that the theft triggered a supernova. The diamond planet is likely the corpse of that companion, its outer layers stripped away until only the carbon core remained, compressed and polished by the explosion's aftermath. For all its lethality, PSR J1719-1438b is a scientific goldmine. Its existence challenges what we thought possible about planetary survival, proving worlds can endure even the most violent stellar environments. And that diamond core, it's a time capsule preserving clues about how carbon behaves under pressures we could never replicate on Earth. So while this glittering abyss might top the list of places you'd never want to visit, it's also a dazzling reminder that the universe's deadliest corners often hide its most extraordinary secrets. Rising from the heart of our galaxy like twin ghosts, the Fermi bubbles stretch 50,000 light-years into space, one above the Milky Way's disk, one below. These colossal structures, invisible to human eyes, glow fiercely in gamma rays, their surfaces crackling with energy equivalent to 100,000 supernova. Discovered in 2010 by NASA Fermi telescope, they resemble an hourglass tipped on its side, its sand replaced with pure radiation. But what cosmic event could blow bubbles this massive? The answer lies buried in our galaxy's violent past. At the center of this mystery is Sagittarius A, the supermassive black hole anchoring the Milky Way. While relatively quiet today, evidence suggests it wasn't always so well behaved. 6 million years ago, a catastrophic feeding frenzy may have triggered a quasar-like explosion, an eruption so powerful it launched jets of plasma at near light speed. These jets, plowing through the galaxy's halo, would have carved out vast cavities, filling them with shock-heated gas and high-energy particles. That's the leading theory behind the Fermi bubbles. They're the fossilized remnants of a black hole tantrum, a tantrum that reshaped our galactic neighborhood in an instant. The sheer scale of these structures defies comprehension. If you could see them from Earth, they'd span half the night sky, each bubble stretching from horizon to zenith. Their edges aren't smooth, they're ragged, rippling with filaments of gas that trace ancient shockwaves, and the radiation inside, a maelstrom of gamma rays, cosmic rays, and X-rays, concentrated enough to sterilize any planetary system caught in their path. Travel through one, and your ship's hull would be sandblasted by particles moving at 99.9% the speed of light. Yet the Fermi bubbles aren't just relics, they're active. Data shows they're still inflating, fed by lingering winds from Sagittarius A. Some researchers believe they might even be leaking, channeling energy into intergalactic space like a pressure valve for the Milky Way. That energy could be seeding the surrounding void with heavy elements, scattering the raw materials for future stars and planets far beyond our galaxy's borders. What's most haunting is the timing. 6 million years ago, when these bubbles began forming, Earth was in the Miocene epoch, its continents shifting, early apes climbing trees. The light from that explosion would have washed over our planet unnoticed. Yet had we been just a few thousand light-years closer to the galactic center, the radiation could have triggered mass extinctions, rewriting the story of life before humans ever walked the Earth. The Fermi bubbles challenge our understanding of black hole behavior. They prove even dormant giants like Sagittarius A can wake in moments of apocalyptic fury, reshaping galaxies in ways we're only beginning to grasp. And they hint at a future danger. If another eruption happens, the bubbles could grow larger, their radiation reaching further into the galactic suburbs where our solar system resides. For now, we're safe, but these silent, glowing ghosts serve as a reminder. The universe doesn't need explosions to be deadly. Sometimes the most terrifying things are the ones left behind. HD 189733b isn't just another exoplanet, it's a cosmic slaughterhouse disguised as a deep blue marble. From space, it glows like a tranquil sapphire, but that serene hue is a lie. This world's atmosphere isn't filled with water vapor. It's laced with vaporized silicon, turning the sky into a swirling storm of molten glass. And if you think hurricanes on Earth are bad, imagine winds screaming at 8,700 kilometers per hour, 7 times the speed of sound. On this planet, storms don't just rage, they flay. Picture stepping out of a spacecraft if you were foolish enough to try. First, the heat would hit you like a blast furnace, daytime temperatures soaring to 930 degrees Celsius, hot enough to melt aluminum. Then the wind would grab you, not with gusts, but with the force of a continuous nuclear shockwave. Your skin wouldn't just burn, it would be sandblasted off by silicon particles moving faster than bullets. The rain here isn't water, it's sideways daggers of molten glass propelled horizontally with enough force to strip flesh from bone in seconds. Even a reinforced spacesuit would last mere moments before its outer layers were etched away like sugar in a sandstorm. The planet's cobalt blue color comes from silicate haze scattering starlight, a cruel irony, since this same haze is what shreds anything that dares enter. But the real terror lies in the wind's sheer violence. These aren't ordinary jet streams, they're supersonic rivers of death, channeled by temperature extremes between the scorching day side and the slightly less scorching night side. The temperature gradient is so steep, it creates a permanent planet-wide cyclone with no calm eye, just an endless maelstrom where the very air acts like a belt sander made of glass shards. For all its fury, HD 189733b is a scientific goldmine. Its extreme weather offers clues about how atmospheres behave under brutal conditions, helping astronomers model climate patterns on other hostile worlds. Some theorists even suggest that similar planets might exist closer to home, not in habitable zones, but lurking in the outer reaches of nearby star systems, their blue disguises hiding storms beyond human comprehension. So while this glass rain hellscape tops the list of places you'd never survive, it's also a grimly perfect laboratory for understanding the universe's most violent weather phenomena. A reminder that sometimes the most beautiful sights in space are also the deadliest. Somewhere beyond the Hydra Centaurus supercluster, hidden behind the Milky Way's dusty veil, lurks a gravitational enigma that defies explanation, the Great Attractor. This immense cosmic anomaly exerts a pull so strong, it's dragging entire galaxies, including our own, toward it at over 2 million kilometers per hour. Picture space itself as a colossal river with galaxies like leaves caught in its current, all flowing toward a point we can't even see clearly. What makes this force so unsettling isn't just its power, it's the fact that we're staring into the gravitational equivalent of a black hole's bigger, stranger cousin, with no idea what's truly at its core. For decades, the Great Attractor was astronomy's blind spot. Its location lies directly behind the Milky Way's crowded disk, a region so packed with stars, gas, and dust, it's like trying to peer through a snowstorm. Only with X-ray and radio telescopes could astronomers pierce the cosmic clutter, revealing a concentration of mass so vast, it bends the fabric of the universe on a galactic scale. Current estimates suggest it contains the equivalent of tens of thousands of Milky Ways crammed into a space just a few 100 million light-years across. Theories about its identity range from the mind-bending to the apocalyptic. Some suggest it's the heart of an enormous supercluster we've yet to map fully, a tangled knot of dark matter and galaxies whose combined gravity dominates our corner of the cosmos. Others propose something even stranger, a dark flow, a remnant imprint from the Big Bang itself, tugging matter toward regions of space beyond the observable universe. Then there's the spine-chilling possibility that the Great Attractor could be an early sign of the Big Crunch, a hypothetical collapse of the universe back into a singularity, where every galaxy, star, and atom eventually smashes together in a cosmic implosion. Visualizing this force is like watching destiny in slow motion. Simulations show galaxies strung along invisible filaments, sliding toward the attractor like beads on a wire. Our local group, including Andromeda and the Milky Way, is caught in this flow, though we're far enough away that the journey would take tens of billions of years. By then, the universe's expansion might render the trip impossible unless dark energy's push loses its battle with gravity's pull. Yet the Great Attractor isn't just a cosmic threat, it's a puzzle begging to be solved. Its existence hints at structures and forces we've barely begun to understand, hidden in the shadows of the observable universe. And while its true nature remains elusive, one thing is certain. In the grand tug of war shaping the cosmos, the Great Attractor holds one end of the rope, and it's pulling hard. At the heart of the Crab Nebula, a 1,000-year-old stellar corpse spins faster than a blender on its highest setting 30 times every second. This isn't just a dead star, it's a pulsar, a magnetized dynamo hurling out twin beams of radiation so intense, they light up the surrounding nebula like a cosmic lighthouse. If you could see these beams with the naked eye, they'd slice through space like invisible scalpels, sweeping past Earth with a rhythmic precision that makes atomic clocks look sluggish. What makes this pulsar especially terrifying isn't just its speed, it's what that speed generates. Each rotation whips up magnetic fields trillions of times stronger than Earth's, turning the surrounding space into a particle accelerator more powerful than anything humans could build. Electrons caught in this maelstrom spiral along magnetic field lines at nearly the speed of light, emitting synchrotron radiation, a blistering glow that paints the nebula in eerie blues and violets. The energy here is so extreme, it mimics conditions just moments after the Big Bang, giving scientists a front-row seat to physics otherwise lost to time. Then there are the jets. Not content with merely spinning, the pulsar fires off concentrated streams of particles from its poles, stretching light years into space. These aren't gentle flows, they're torrents channeled by magnetic fields into narrow columns moving at relativistic speeds. Anything caught in their path gets bombarded with enough high-energy radiation to strip molecules apart atom by atom. Yet for all their violence, these jets are strangely beautiful celestial geysers, sculpting the nebula's delicate filaments into swirling, intricate patterns. The Crab Nebula itself is a graveyard with a story. In 1054, Chinese astronomers recorded a guest star blazing so brightly it was visible in daylight for weeks. That guest was a supernova, the explosive death throes of a massive star whose core collapsed into the pulsar we see today. The expanding wreckage now spans 12 light-years, a tangled web of gas and dust still rushing outward at 5 million kilometers per hour. Inside, shockwaves ripple through the nebula, heating gas to millions of degrees and scattering heavy elements like oxygen and iron, the same elements that make up our bones and blood. For astrophysicists, the Crab pulsar is a gift. Its relentless spin provides a natural laboratory for studying extreme gravity, magnetism, and particle physics. Its beams sweep past Earth like clockwork, allowing precise tests of Einstein's theory of relativity, and its nebula, a time capsule of stellar death, revealing how explosions seed the cosmos with the ingredients for new stars, planets, and life. But here's the twist: the Crab Nebula is also a cosmic time bomb. That pulsar won't spin forever. Over millennia, its energy will dissipate, its beams will fade, and the nebula will expand until it dissolves into the galactic void. What remains will be a cold, silent neutron star, a tombstone for one of history's most violent stellar spectacles. Until then, the Crab keeps spinning, its light a fleeting echo of the day a star died and science gained one of its greatest teachers. Ogle 2005 BLJ390LB isn't just cold, it's a frozen tomb drifting through interstellar space, where temperatures plunge to -220 degrees Celsius, so far below freezing that even the air would turn to snow. This exiled world orbits a dim red dwarf so faint, its light feels like a dying ember compared to our sun's blaze, Picture endless plains of solid nitrogen and methane ice stretching toward a horizon forever locked in twilight, where the sun overhead is barely more than a bright star in a perpetual midnight sky. At these temperatures, metals become brittle as glass, gases freeze into glaciers, and any semblance of an atmosphere has long since collapsed into a frozen wasteland. What makes this planet especially haunting isn't just its cold, it's the silence. Most exoplanets we discover whirl around active stars, caught in the turbulence of solar winds and magnetic storms. But Ogle 2005 BLG390Lb's star is so weak, its solar system might as well be in stasis. No auroras dance in the sky here, no radiation belts churn. Just an eerie stillness broken only by the occasional creak of ice shifting under the pull of a gravitational whisper. This isn't a world on the edge of habitability. It's a graveyard of what could have been, a cautionary tale of how solar systems wind down when their stars fade into obscurity. Yet buried beneath kilometers of ice might lie clues to a more violent past. Some astronomers theorize this planet was once a gas giant, its thick atmosphere frozen solid after being flung into a distant orbit by gravitational encounters with larger worlds. Others suggest it could be a failed Earth, a rocky core that never had the chance to develop life before its star grew too dim to sustain liquid water. The truth might be even stranger. Infrared scans hint at traces of carbon monoxide ice on the surface, a chemical signature that suggests this world could have briefly hosted complex chemistry before the cold locked everything in place. For scientists, Ogle 2005 BLG390Lb is a time capsule. Its icy crust preserves a snapshot of what happens to planets when their star systems run out of energy, a fate that might await countless worlds in the universe's distant future. And while it seems lifeless now, there's a chilling possibility. What if the cold isn't the end but a pause? Some extremophiles on Earth survive in similar conditions, frozen for centuries before thawing back to activity. If by some miracle this world star flared back to life, or if it was captured by a younger system, that glacial silence could shatter in an instant. Until then, it drifts, a monument to the universe's quietest, most patient apocalypse. Most cosmic structures loom large galaxies, superclusters, great walls of matter stretching across the universe. But the Boötes supervoid doesn't loom, it haunts, a staggering 330 million light-years of near-nothingness. This isn't just an empty patch of space, it's a gaping hole in the fabric of reality, so vast it could swallow thousands of galaxies whole without leaving a trace. If the universe is a bustling city, the Boötes void is a deserted district where streetlights flicker out one by one, leaving only silence and shadows. What makes this void so unsettling isn't just its size, it's the unnerving lack of what should be there. Based on the average density of the cosmos, this region should host around 2,000 galaxies. Instead, astronomers have found fewer than 60, scattered like lost travelers in a desert. The emptiness here isn't just a fluke, it's a mystery that challenges our understanding of how the universe organizes itself. Some theorists call it a universe-scale flaw, a cosmic manufacturing error left over from the Big Bang where matter simply forgot to clump together. Others whisper about darker possibilities. Could this be the imprint of an ancient collision with another universe, a bruise left by something beyond our reality? Then there's the cold spot. Buried within the void's depths is a chilling anomaly in the cosmic microwave background, the afterglow of the Big Bang itself. This spot is too cold, as if something sucked the energy right out of it. One explanation, the void's emptiness acts like a gravity well, stretching light that passes through it and draining its energy over billions of years. But even that doesn't fully account for the temperature drop. Could it be evidence of exotic physics wormholes, parallel dimensions, or quantum entanglement on a cosmic scale? For hypothetical explorers, the Boötes void would be the ultimate test of sanity. drift into its heart, and the nearest galaxy would be so far away, its light would take millions of years to reach you. The night sky wouldn't glitter with stars, just a smattering of faint, lonely points in an ocean of black. Even the cosmic microwave background, the universe's oldest light, would feel dimmer here, like a dying ember. It's a place where the universe forgets itself, where the rules of structure and clustering seem to pause. Yet this eerie emptiness might hold clues to the cosmos's deepest secrets. Voids like Boötes aren't just accidents, they're part of the universe's skeleton, the negative space that shapes the great walls and filaments of galaxies. Studying them could reveal how dark energy pushes the universe apart, or how quantum fluctuations in the early cosmos set the stage for everything we see today. So while the Boötes supervoid might feel like a cosmic oversight, it's also a window into the universe's most fundamental blueprints, proof that sometimes nothingness speaks louder than stars. Why Canis Majoris doesn't just defy expectations, it shatters them. This hypergiant star is so colossal, it could swallow our entire solar system up to Saturn's orbit without breaking a cosmic sweat. Picture a sphere so vast, light would take over 8 hours to circle its circumference, compared to just 14 seconds for our Sun. If placed at the center of our solar system, its scorching outer layers would brush past Jupiter, reducing every planet in its path to vapor. But size isn't what makes this star truly terrifying, it's the fact that it's coming apart at the seams. This isn't a stable, simmering giant like Betelgeuse. Why Canis Majoris is a runaway furnace on the brink of self-destruction, hemorrhaging mass at a rate that defies logic. Every few decades, it coughs out gargantuan eruptions, not mere solar flares, but explosions so violent they eject entire Jupiter-sized chunks of stellar material into space. In 2007, astronomers witnessed one such event, a plume of gas and dust stretching 30 billion kilometers, far enough to span the distance from Earth to Pluto 7 times over. These aren't hiccups, they're death throes, the star's outer layers sloughing off as its core teeters on collapse. What's fueling this chaos? A dying heart. Deep inside, why Canis Majoris has already exhausted the nuclear fuel that once kept it stable. Now, it's burning through heavier elements in fits and starts, its fusion reactions growing increasingly erratic. The result, a surface roiling with convection cells the size of solar systems, where temperatures swing from 3,000 to 4,000 degrees Celsius in turbulent waves. The star's gravity, barely strong enough to hold itself together, allows massive dust clouds to escape, forming a nebula of its own, making a funeral shroud woven from its disintegrating body. And then there's the inevitable, a supernova. When this hypergiant finally detonates, whether tomorrow or 100,000 years from now, the explosion will be so bright it could outshine the full moon from Earth's perspective, visible even in broad daylight. The blast won't just light up the sky, it'll unleash a gamma-ray burst with the energy of 1 billion suns, sterilizing nearby star systems in an instant. The shockwave will rip through surrounding space at tens of thousands of kilometers per second, carving cavities in interstellar gas that will linger for millennia. Yet for all its violence, why Canis Majoris is a treasure trove for astronomers. Its death throes offer a preview of what our own sun might experience billions of years from now, albeit on a far grander scale. The star's intricate nebula, rich with molecules like titanium oxide and silicon dioxide, hints at how such giants seed the cosmos with heavy elements, the same stuff that makes up planets and even life. So while this hypergiant may be a ticking time bomb, it's also a cosmic alchemist, forging the ingredients of future worlds even as it prepares to annihilate itself. A reminder that in space, the line between creation and destruction is often vanishingly thin. Deep within the Fermi bubble's swirling gamma-ray glow, some astronomers speculate a ghost might lurk, an entire galaxy made not of stars and dust, but their mirror opposites, antimatter. Imagine a spiral like our Milky Way, but every particle spinning within it carries the opposite charge of its familiar counterpart. Protons here are negative, electrons positive, and should this phantom realm ever brush against our own, the resulting annihilation would make supernova look like firecrackers. Matter and antimatter don't just collide, they obliterate each other with perfect efficiency, converting their entire mass into pure energy. A single gram of antimatter meeting its counterpart releases the explosive force of 43,000 tons of TNT. Now scale that to galactic proportions, stellar winds of antiprotons clashing with normal hydrogen, entire antimatter stars plowing through nebulae made of regular atoms. The contact zone would light up with gamma-ray flares brighter than any quasar, as quadrillion-ton chains of annihilation rippled across thousands of light years. The shockwaves alone could trigger star formation in nearby clouds or tear existing solar systems apart. The Fermi bubble's extreme energy signatures make them prime hunting grounds for such a phantom. Some theorists suggest their gamma-ray excess might betray the presence of leaking antiparticles drifting from an antimatter galaxy's outskirts. If true, this structure couldn't be young. Its very existence would require surviving for billions of years without touching normal matter. That means floating in a near-perfect void, its antistars separated from regular galaxies by vast, empty motes of space. One wrong gravitational nudge, though, and the mote collapses. What would annihilation look like at the frontier? Picture two galactic arms grazing each other, a seemingly gentle touch that unleashes hell. First, the interstellar gas clouds meet, their particles annihilating in bursts of gamma rays. Then the stars themselves, their antimatter cores reacting with surrounding normal matter in runaway reactions. A single antimatter star the size of our Sun, straying into a nebula, would glow with the light of 100 supernovae as it consumed its surroundings. And if a black hole lurked in either galaxy, the infalling antimatter would produce jets of gamma rays unlike anything seen in nature. Yet the most haunting question isn't how such a galaxy would die, it's how it could exist at all. The Big Bang should have created equal parts matter and antimatter, yet we live in a universe dominated by the former. An antimatter galaxy would imply pockets of the cosmos somehow escaped this balancing act, surviving against inconceivable odds. Perhaps it's a relic of a far larger antimatter realm, now faded, with this lone galaxy as its last holdout. Or maybe it's evidence of physics we've yet to imagine, regions where the rules of charge and symmetry twist into new shapes. For now, the antimatter galaxy remains speculative, a tantalizing what-if scribbled at the edges of astrophysical models. But should it prove real, its discovery would rewrite cosmic history. Not just as a curiosity, but as proof that the universe's most extreme experiments weren't confined to the Big Bang. They're still out there, lurking in the shadows, waiting to unravel everything we think we know. Something is pulling at the fabric of our universe, not just a gentle tug, but a relentless, invisible current dragging entire galaxy clusters toward some unseen horizon. Astronomers call it the dark flow, and it's one of cosmology's most unsettling mysteries. Picture this: hundreds of massive galaxy clusters, each weighing trillions of suns, all drifting in the same direction at breakneck speeds over 2 million miles per hour, as if summoned by a cosmic siren call. The problem: there's nothing in the observable universe massive enough to explain this motion. Nothing we can see, at least. This isn't just gravity as we know it. The dark flow defies the standard model of the universe's expansion, where galaxies should scatter evenly like raisins in rising bread dough. Instead, these clusters are racing toward a specific patch of sky near the constellations Centaurus and Hydra, their movement too coordinated, too purposeful to be random. Some researchers believe the culprit might lie beyond the edge of our observable cosmos, an unimaginably vast concentration of mass, perhaps an entirely separate universe, exerting gravitational influence from the other side of reality's curtain. The implications are staggering. If the dark flow is evidence of another universe brushing against ours, it would be the first tangible hint of a multiverse, a cosmic neighborhood where our universe is just one bubble in an infinite foam of others. Imagine two soap bubbles floating in a sink, their surfaces barely touching. Where they meet, gravity might leak across, creating these strange unidirectional tides. The galaxy clusters caught in the flow, they're like leaves swept along a river that flows into the unknown. Yet skepticism lingers. Could this motion be an illusion, a trick of incomplete data or measurement errors? Some argue it might trace back to primordial gravitational waves, ripples from the Big Bang itself, still echoing through spacetime. Others propose even wilder ideas, cosmic strings, theoretical defects in spacetime structure, acting like invisible ropes yanking matter toward them. But the most haunting possibility remains the multiverse. If true, the dark flow isn't just a curiosity, it's a cosmic breadcrumb, leading to realms so distant their light will never reach us. For now, the dark flow taunts us with questions. What lies beyond the observable universe's edge? Are we being pulled toward something, or is something much larger being pulled toward us? Every new observation deepens the mystery, reminding us that the universe's greatest secrets might not lie in the stars above, but in the unfathomable darkness just beyond our view. The Black Widow pulsar earns its name from nature's most brutal romance, a neutron star that's slowly vaporizing its companion, just like its arachnid namesake devours its mate. Locked in a deadly orbital embrace, this binary system is a cosmic horror show where one star's gravity siphons material from the other, leaving behind a trail of superheated gas and radiation. But unlike Earth spiders, this celestial predator doesn't just consume, it annihilates with the precision of a particle accelerator, turning its partner into little more than stellar plasma. At the heart of this carnage is a pulsar spinning dizzyingly fast over 600 times a second, its beams of radiation carving through space like a lighthouse gone berserk. Every rotation whips up a magnetic storm so intense, it blasts its companion star with enough energy to strip away entire layers of atmosphere. Think of it as a cosmic sandblaster, eroding the star's surface at a rate that would evaporate a planet like Earth in minutes. What's left is a ghostly husk, its outer gases pulled into a swirling disk around the pulsar, glowing white-hot before vanishing into oblivion. The companion star never stood a chance. Once a healthy sun-like body, it's now reduced to a smoldering cinder, its orbit tightening like a noose as the pulsar's gravity drains its life away. Gas torn from its surface forms a grotesque tail, stretching thousands of kilometers into space, a stellar comet caught in the act of being disassembled atom by atom. And the pulsar isn't just feeding, it's accelerating. The stolen mass fuels its spin, making it even more lethal, its radiation beams growing sharper, more focused, like a predator honing its claws. But here's the cruelest twist: this destruction is also creation. The violent interactions in the Black Widow system forge heavy elements: gold, platinum, uranium, scattering them into space like cosmic confetti. In a billion years, those atoms might become part of new stars, planets, even life. So while one star dies, its remnants could seed the birth of countless others. Astronomers study systems like this not just for their brutality, but for what they reveal about extreme physics. The Black Widow pulsar is a natural laboratory for testing Einstein's theories, its gravity so strong it bends light into loops. Some researchers even speculate that, given enough time, the pulsar might completely consume its partner, leaving behind a lone neutron star with a tragic, cannibalistic past. Until then, it spins on a glittering tombstone in the making, and a chilling reminder that in the cosmos, love and destruction are often two sides of the same coin. So there you have it, the universe's greatest hits of horror, where even the laws of physics surrender to chaos. To recap the top 5 deadliest champions of destruction, we start with Sagittarius A, the supermassive black hole lurking at our galaxy's core. an invisible predator shredding stars into cosmic spaghetti. Then there's the magnetar, a neutron star with a magnetic field so intense it could erase your atomic structure from 1,000 kilometers away. Third, Venus, our so-called twin planet, where the air crushes like an ocean, the rains burn like acid, and the surface broils hotter than a pizza oven set to apocalypse mode. Fourth, the Boomerang Nebula, a cosmic freezer so cold it defies the very concept of temperature, chilling matter to within 1 degree of absolute zero. And finally, the Fermi Bubble's twin gargantuan spheres of radiation expanding from the Milky Way's heart, remnants of a black hole tantrum powerful enough to reshape our galaxy. But here's the unsettling truth: these aren't just random hazards. They're proof that the universe isn't just dangerous, it's trying to kill us. Every hypervelocity star, every gamma-ray burst, every rogue black hole drifting unseen through the void is a reminder that existence itself is a high-stakes game of survival, and Earth's fragile oasis is just a temporary reprieve. The cosmos doesn't hate us, it doesn't even notice us, and that's the real terror. So tell us, which of these cosmic nightmares unsettled you the most? Was it the crushing depths of Venus or the silent, inescapable hunger of a black hole? Drop your thoughts in the comments, and while you're at it, hit subscribe to join us as we keep unraveling the universe's darkest secrets. Because out there, in the infinite dark, the next great cosmic hazard is already forming, and trust us, you'll want a front row seat when we uncover it. Until then, keep looking up, but maybe sleep with one eye open. End scene. Zoom out into a swirling black hole, swallowing the screen into darkness.